Okay, so given these spectra and this molecule, can you match one of these spectra to this molecule, these carbon NMR spectra? So this is a very common problem you're going to see on your exams. Maybe not in this exact formula, I'm sorry, exact scenario, but you're going to get NMR problems, whether it's matching or predict the molecule, predict the structure, predict the spectra. So this one's pretty easy. Multiple choice. We got 4 carbon NMR spectra here. We have our molecule. Let's match it. If you want, pause it right now, take a screenshot, work through it on your own, come back, find out the answer. If not, let's get through it right now. So we have our molecule here. It's this ester with an alkene on the end. So what I like to do is the first thing I want to do in carbon NMR is figure out how many unique carbons there are in our molecule. So let's start, we'll go left to right. We have 1, then we have 2 for the carbonyl, and then 3 and 4 for our alkenes. So then the first thing I like to do is I like to eliminate like blatantly wrong answers. I find that to be the easiest way in any subject you're taking. So we have 4 signals. Are there anything with more than 4 signals? So, or less than 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. All right, so we can definitely say that D is out by D. Then what we can do is I like to look at, if you look at the alkene region, it's kind of tough. Then you can go by functional group, but remember the alkene region is roughly around 100 to 150, and we have 2 signals. Each of these kind of fits that. It's kind of hard to say. So what we can do is, it's not really definitive. So what we can do is we go to the carbonyl. So remember the carbonyl region is around 200 to 160, give or take. But the position of our carbonyl carbon, which they all have, if one of them didn't have a carbonyl carbon, we could immediately get rid of it. But they all have it. But the position of the carbonyl carbon is very distinctive in the NMR. So you notice these two are around 170, a little less than 170, just say 170. Whereas this one is around 200. So this one around 200 is much more indicative of a ketone or an aldehyde, whereas these two are much more indicative of a ester, amide, or maybe even like an acid. So we can say that A is gone. So now we are left with C and B, and like we said, they both have 2 alkene signals, so we can't really say one or the other. And they both have what we're assuming is that ester carbonyl. So what do we have left? We have these alkyl regions here, which is, your little methyl group. So what do we see the difference is? Well, this one is at 20 ppm, whereas this one is at like 50 ppm. So this is more in line with just a straight up alkyl chain, like sp3 hybridized CH, nothing around it. This one's downshifted pretty heavily. Well, what would cause that? Well, if it was next to an oxygen, that would downshift it pretty hard, and that would put it right in the range of, say, 40 to 80. It's sitting at 50. So I'd be willing to bet money that that is our spectra right there. So I'm going to eliminate C, and then B is our answer. So hope that practice was helpful for you guys. As always, drop below in the comments what you thought of the video, what you're struggling with in class, what you want to see a video on. As always, you can send me a DM. My DMs are open. I do answer them. If there's something you're struggling with in class and you don't understand it, you got something wrong in the last exam, you don't know why, send it over to me. I'll make a video. We'll walk through it together.